Okay, on this worksheet, you can follow through as I go through and show you how you should have answered your questions and make corrections where necessary because your worksheet has to be 100% correct when we do this. So let's start this. So on this first problem, you're given a set of data where you're going to be graphing the time here against the distance. One of the things you need to note always is that time is always going to be on the x-axis. And the other variable will always be on the y-axis. So we're always going to put time down here on the x-axis. Some of you had that reversed on your original problem, and then this will be for whatever variable. In this case, it's going to be distance on this problem. The other thing is we need to scale the units out so that they look proportional. So you always have to figure out what the individual boxes are going to represent in terms of an even number. It's just not putting the numbers on there as you see. You got to scale them out, that every box is equal to either 5 seconds or 5 meters depending upon. So when I did this, this is how I went about graphing my data. I made for the time unit down here, every box was 1 second. And you can see I labeled it as time. My y variable over here, that was distance, and I made every box 10 meters because I had to go all the way up to 125 meters. And then I just simply plotted. So at 0, 0 is that. At 1, it was 50 meters. At 2, it was 75 meters. After I did that, then I drew a line the best I could to connect all the dots. So it would look like that when I was finished. So I have a time and a distance graph here. Time is always on the x-axis. Distance in this case will be on the y variable. So on this problem here, you're asked to determine how to figure out and calculate slope. So what we know here is that slope is equal to the rise over the run. That's our equation. That should be on your equation note card. The rise is always going to be the height along the y-axis, whereas the run will always be the length on the x-axis. So when we're calculating the slope here, for this line, slope is equal to the rise, which would be the height here on the y-axis, that would be 125 meters, divided by the length over here on the run, which is the x-axis, and that would be 5 seconds. So when we calculate this, 125 divided by 5 seconds would give me an answer, and I'll write it over here, of 25 meters per second. That would be my slope of the line. Now the question is, what does, up here it says, what does slope of a graph mean? Well, when you're doing the slope of a distance and time graph, that is always going to give you speed. It'll always measure out to give you speed. Okay, so this problem here is using the data from the graph in the previous problem that you did, but what it's asking you to do here is simply calculate speed. This is a simple math problem, and we're going to use the time of 2 seconds. So to do a math problem, we need our equation. So speed is equal to distance divided by time. The distance here for 2 seconds is 75 meters. That's the distance value you'll use. The time, of course, is going to be 2 seconds. When we run it through our calculator, we come up with 37.5 meters per second. And don't forget, anytime you do a math problem, you want to put a box around your final answer. So that's just a simple speed equation. This one is asking you to calculate the speed after 3 seconds. So again, speed is equal to distance divided by time. At 3 seconds, the distance is 90 meters. So it's 90 meters divided by 3 seconds. And that would be 30 meters per second for this one. On the next problem, it's asking you to calculate what the speed would be after 5 seconds. So again, we're going to use the distance value here of 125 meters, because that's what it was measured at 5 seconds. So again, my equation is speed is equal to distance divided by time, which would be 125 meters divided by 5 seconds. When you run that through your calculator, you get 25 meters per second for that speed. On this one, it says, what is the average speed between 2 and 4 seconds? Well, we already know from a previous problem that 2 seconds we had a speed equal to 37.5 meters per second. So that came from problem number 1. That came out of problem number 1. So I'm not going to recalculate that because you can look at that. But now I need to know what the speed is for 4 seconds because I have never done that one yet. So for 4 seconds, if we're going to do the 4-second speed, we know that speed is equal to distance divided by time. The distance at 4 seconds is 110 meters divided by the time of 4 seconds. So that would be, let's see, 27.5 meters per second. So that's at 4 seconds. And 2 seconds, so we got 4 seconds here and 2 seconds. So we need to do an average. So the average, again, we just add the two together. We have 37.5 meters per second plus 27.5 meters per second. There's 2 of them, so we divide it by 2. So when you add the 2 numbers together and divide, you would come up with 32.5 meters per second as your answer. That's a little better. So this one you basically just had to calculate the 4-second one. You already knew what 2 seconds were. Add the 2 together to get an average and go from there. So in this problem it's asking you for what the average speed is between 4 and 5 seconds. So we already just did 4. So we know that the average speed for 4 seconds would be equal to 27.5 meters per second. And from a previous problem earlier, we found that the average speed of 5 seconds was 25 meters per second. So again, to figure out the average here, we're just going to add the 2 together. So we got 27.5 meters per second plus 25 meters per second. We have to divide it all by 2. When we add them together, divide them by 2, I come up with 26.25 meters per second. That would be the average speed between the time of 4 seconds and 5 seconds. Okay, on this problem, we're going to be doing a graph here where we're graphing time, and this time it's going to be speed. So again, the reminder is that time is always found on the x-axis. So when we set up our graph, time is going to be down here on the x-axis, speed would be the other variable, and that'll be over here on our y-axis. So when I graphed this out, I scaled it out. This time I made each x-axis time unit one box. So it went from 0 to 10. And then I scaled out over here using 5s. Every box equals 5 for the speed. Then it was scaled out from 0 to 75, so things would fit. Then I plotted my data points. So at 0 time, 0 speed. At 2 seconds, I had 10 meters per second. At 4 seconds, I had 20, and I plotted those out and connected the dots. The next thing it's going to ask me to do is calculate the slope. Once again, slope is always equal to the rise over the run. And again, we note that the rise is always the height on the x-axis, so how high it goes, whereas the run is always the length here on the x-axis. And I think I said rise was the axis, so the y-axis. So we see that it goes up as high as 50 meters per second here, and the length is 10 seconds here. So to calculate the slope, again, we would have the slope, which is equal to the rise, 50 meters per second, divided by the run of 10 seconds, and I'm going to write the answer up here. So 50 divided by 10 would be 5, and the units are meters per second squared. Of course, that type of graph where we have time and speed, this calculates, the slope will calculate acceleration. The next problem says that as time increases, so as we get bigger in time, what happens to speed? Well, if you notice, the speed value also starts to go up. It increases over the time, which is also increasing. So what happens to speed? It also increases. As one goes up, the other goes up. This one is really an easy one because I don't even have to do any math. I'm using my graph. It says at a time of 5 seconds, what would be the speed? So basically I go to 5, I go up to where I hit my graph, and I go over, and I notice that the speed here would be 25 meters per second. So I didn't even have to do any math. I just used the graph and the data points to figure that out. Similarly, the same thing happens in reverse. It says at what time would the object reach a speed of 45 meters per second? So I go over here and I find 45. I go over until it hits the graph line. Then I go down to where it meets the time. And here the answer would be 9 seconds. 45 is right here. So again, I'm not even having to do any math. I don't even have to get out my calculator. I can simply just use my graph and the data points to figure that out. Okay, on this one we're going to do distance versus time. We're going to plot a graph distance versus time. Just a reminder that time is always on the x-axis. The distance here will be on the y. So when I do this and I plot this out, I scaled it out. Here I made each of my time units 5-second increments, so I went from 5 to 60. The distance I left as every 5 units, so it went up from 5 to 75. When I plot my data and I connect the dots, it should look like this. And again, if I was to calculate the slope on this, the slope of this kind of a graph would always equal speed. I'd be figuring out the speed, distance divided by time. So in this one it says what is the average speed at 20 seconds? So we're going to use the values at 20 seconds of time. Again, speed is equal to distance divided by time. So the distance at 20 seconds was 12 meters. And that really should say meters right there. That second shouldn't be there. divided by the time of 20 seconds. When I run it through my calculator, I get 0.6 meters per second as an answer. Here on this problem number 2, we're going to figure out the speed at 30 seconds. So we'll use the values over here. Again, speed is equal to distance divided by time. The distance at 30 seconds is 20 meters. Time at 30 seconds. 20 divided by 30 is 0.66 meters per second. And of course, a box around the answer. This one we're going to figure out acceleration. We're going to figure it out between the time of 20 and the time of 30 seconds. So first we need our acceleration equation. So acceleration is equal to final velocity minus the initial velocity divided by the time it takes to go from those two speeds. Final velocity would be the last recorded speed. Well, that would be at the 30-second. So the speed at 30 seconds was 0.66 meters per second. We calculated that in the problem before. We have to minus the last recorded speed, which would be the speed at 20 seconds. Well, from problem number 1, we found that that was 0.6 meters per second. And then we have to divide it by the time that it takes to change all of that. Well, the difference between 20 and 30 is 10 seconds. So in 10 seconds time, that's what the speeds changed. So when we calculate this out, we take 0.66 minus 0.6 and then divide the whole thing by 10. You come up with an answer of 0.006 meters per second. And of course, acceleration has a time squared unit because if we remember that second actually moves up and is multiplied by the other second. And then of course, we'll have a box. So that's what the speed changed between those two time units. In this problem, we're going to just find speed at 40 seconds. So we'll use the data at 40 seconds to do that. So again, speed is equal to the distance divided by time. The distance at 40 is 30 meters. The time is 40 seconds. 30 divided by 40 is 0.75 meters per second. And our last problem here is we're going to figure out the speed at 60 seconds. So we'll use the data here. So again, speed is equal to distance divided by time. The distance is 56 meters divided by the time of 60 seconds. 56 divided by 60 is 0.93 meters per second. Okay, that concludes this answer